So a number of the examples that I've been looking at in here and sort of case studies we've been using deal with experiments. And in general, there's sort of this idea that an experiment is some sort of a formal thing that's done in a laboratory where, like, maybe somebody puts on a white laboratory coat and they measure things in beakers or something like that. And of course, I mean, we do get the idea of an experiment from the hard sciences like chemistry and physics and whatnot. But experiment is really a much more expansive notion than that might suggest. And in particular, I'm going to use a really broad definition of experiment that will take in a lot of things you wouldn't necessarily think of as being like a classical experiment, because really, when you get down to it, a lot of the work that we do in language and linguistics really is an experiment of some sort, even if it's not quite as formally set up as you might find in another kind of science. So here's a very expansive definition of an experiment. It's any deliberate, systematic collection of empirical facts that's analyzed to provide evidence for or against some general hypothesis. And so this will absolutely include, putting various kinds of liquids in beakers and measuring what kinds of compounds they have in them. But this would also take in, laboratory experiments like the example with the lexical decision task that we looked at earlier. It would take in asking people for their linguistic judgments about a set of sentences. Are these well-formed sentences in your language? Or words? Do these sound like possible English words? Those would also count as experiments. If you go into a classroom and try to observe the effects of some teaching intervention on student attitudes or student outcomes, that's an experiment. If you survey the teachers or the students about how they felt about some kind of classroom exercise, that's also an experiment. If you walk out on the street corner and ask people who they're going to vote for in the election, that's an experiment. It might not be a very well designed one, but I want to encourage you to think about experiment as being a really broad category that takes in almost any meaningful empirical exercise that you might do in the course of doing research, right? Now, obviously, this is a kind of long and involved definition, and there's a lot of words in here that represent constructs, and some of those constructs need to be unpacked a little bit. And this will also help indicate ways to think of experiments that go beyond just the sort of classical laboratory setup, because it's a very useful framework for thinking about research designs. Now, an experimental setup can be weak on any one of these criteria I'm about to go through. But as long as there's some sort of general presence of these elements, I think it's fair to call something an experiment. So, starting with deliberate, right? This is a deliberate collection of empirical facts. And what that means is, you did it on purpose. It's for that purpose. So if you take a pre-existing corpus and then you analyze something in it, I wouldn't describe that as an experiment necessarily. Although it should be clear that the mode of analysis is going to be very similar. We're going to be looking for the same kinds of things in a corpus study that we're looking for in an experiment, but I would draw a distinction between the two. Systematic. What does that mean? Well, here's an attempt to explain what systematic means. The researcher sets out to examine a specific set of materials with regard to a specific set of features. And the researcher attempts, whenever possible, to use the same methodology for each observation. So you're not just sort of going out there willy-nilly in the world and saying, oh, look, I saw something over there, and then look, my cousin saw this other thing last week, right? You're trying to observe a specific set of materials, and you're trying to do each observation in the same way. That's what makes an experiment systematic. Now, that can still be fairly informal procedures, like asking somebody if they think a word is well formed or how they felt about this communicative language teaching exercise. But as long as you're making those observations in the same way, that's a systematic effort to collect data. Empirical, that means of or pertaining to things that happen out there in the world, right? Where those things that happen out there in the world can still be things that are inside a human mind or brain. In fact, a lot of what we do in linguistic sciences are based on things that are going on internal to other humans. They're still out there in the world in the sense that they can be at least indirectly observed, or you can draw inferences about them by looking at things that are palpable out there in the world, that can be seen or heard or measured in some way, right? It's a collection of empirical facts that's analyzed. That is, you don't just throw the data in a spreadsheet and say, here's the results of my experiment. The data are going to be summarized or modeled in some way that allows us to draw conclusions about different subsets of observations, different groups of things that we saw in the data. You're going to try to reach some conclusion about what happened by organizing the data. And that can be very, very simple. You might be, averaging a bunch of data points, or it can be extremely complex with fancy statistical models. But the point is that you're trying to make something out of the data that you collect. You're not just sort of letting the data sit there as a bunch of observations. You're organizing them. That's what it means to analyze data. And you're looking for evidence for or against some general hypothesis. And what I mean by that is that when you do an experiment, or most kinds of research studies, you're looking at some set of data. And those might be quantitative data, or they might be something else. But you're doing that in order to teach us something about the world beyond the experiment, not just the world of the experiment itself. If I'm running my lexical decision task on adult French learners, I'm not trying to figure something out about how lexical decision tasks work with adult French learners in a laboratory. That's not the point of the experiment. The point of the experiment is to try to learn something about the linguistic knowledge of adult French learners in general, beyond this particular task in the laboratory. So its generalization also makes part of the definition of what research is, what an experiment is. So these are all important elements. And as you can see, these are not things that are limited to sort of narrow technical hard science laboratories. These are concepts that can be applied to any number of research topics and research approaches in a whole bunch of different fields. Now, when we start doing experiments, we're basically limited to sort of testing for differences between different observations. That's mostly what you can do with an experiment. And oftentimes we're evaluating differences between the data that we've observed and something that we would expect if the research hypothesis weren't true. And this is often referred to as a null hypothesis. And a lot of the experimental frameworks that we find in linguistic sciences are null hypothesis testing frameworks. And so it's important to think a little bit about what null hypotheses are. One way of thinking about this is that you make some observations, you get some data, you analyze it, and then you try to explain why the data look the way they do. But presenting your analysis of the facts that you found is generally not considered enough for a successful research project. You have to also show that it's better than some other alternative, or maybe better than any other alternative. And so generally, the sort of simplest alternative that you can imagine is what we refer to as the null hypothesis. Now, as we'll see shortly, there can also be other less simple alternative hypotheses that you might want to test. And the null hypothesis is extremely limited in some ways. And it's maybe not the best way to think about your research, but it certainly is an important concept in the world of research, and it's worth knowing something about null hypothesis and what that means, right? But another way of stating all of this is that when we get some facts, or when we ask a question, that question should almost always be ending in the phrase, compared to what? So what do I mean by that? Well, we'll get there in a second. So a null hypothesis, first of all, it's not like a totally concrete, clear, automatic definition. It's a kind of a fuzzy notion, right? So we'll see some cases later where it's not obvious to even define what a null hypothesis would be. And then there's going to be cases where there's certainly more than one null hypothesis possible. But in general, the general form of the null hypothesis is going to obviously depend on the hypothesis that you're testing. This is sometimes called the experimental hypothesis. And so you're testing something of the form, it is the case that P, where P is some positive proposition, right, any claim that you might want to test about the world. If that's what you're testing, then the null hypothesis will generally be it is not the case that P. So some examples. If the hypothesis in my research is that students score higher on vocabulary tests after being given a word's definition and seeing it used in context, then the null hypothesis is going to be super straightforward. It's just that students do not score higher on vocabulary tests after being given a word's definition and seeing it used in context. Right? So totally straightforward in this case. We're going to be looking at their scores and comparing them to something else. We'll get there a little bit later. And the question is going to be whether the scores go up or the scores don't go up. Right? So the null hypothesis is not the opposite of our experimental hypothesis. It's not that scores are going to go down. It's just that they're not necessarily going to go up. That's what we're comparing here. Here's one from phonetics. Vowels are shorter before voiceless coronal stops than voiced coronal stops in American English. Right? That's a hypothesis you might want to test. Happens to be true in American English. What's the null hypothesis? It's not that vowels are longer before t than d. It's that the duration of vowels does not differ before t and d. That's the null hypothesis. It's the complement of the experimental hypothesis. It's sort of everything else. It's not the opposite necessarily. Here's one. All languages with subject, object, verb, word order also have postpositions. This one is a broad typological claim about syntax. It is not 100% true, although it is a strong tendency cross-linguistically that many or most languages with subject, object, verb, word order also have postpositions, which are like prepositions, except as the name suggests, they come after the noun that they're modifying rather than before it. What would be the null hypothesis you might want to compare this to? Well, it's not going to be some other specific word order unless you have a theoretical reason for thinking about another word order. It's just going to be there's no relationship between the presence of SOV word order and the presence of postpositions, right? You can have one and not the other. You can have the other but not the first thing. You can have both of them. You can have neither. There's no relationship whatsoever. That would be a null hypothesis. Finding that there is a relationship constitutes an empirical discovery in need of an explanation. So here already, this is getting a little bit fuzzier, like wasn't totally clear what the alternative hypotheses would be here. I've picked out this one. I could imagine other possibilities you might want to compare this to. Sometimes the sort of straightforward null hypothesis is easy to formulate, but is totally useless, right? So here's an example. The Sardinian word pigai is a noun. So what's your null hypothesis going to be? I mean, the sort of straightforward one would be pigai is not a noun, which, I mean, I guess that's something that you could formulate, but that's not going to help at all. It's not specific enough to really be able to investigate even on its own. And so the point here is that there's a whole bunch of other obvious alternatives that are not necessarily null hypotheses in this limited sense, but they're going to make much more sense as comparisons. Namely, pigai is a verb, pigai is an adjective, pigai is some other category of speech. Yeah, these are going to be just much more useful kinds of hypotheses to compare this to in this kind of an investigation. Incidentally, pi is in fact a verb, and it means to drink or to take something. And then there's cases where the entire idea of sort of null hypothesis begins to break down. And so this is going to be more common in sort of more theoretical settings. So a lot of these examples are going to be from syntax or from parts of speech. So here's an example. English yes-no questions are formed by inverting the order of the subject and the auxiliary verb of the corresponding declarative. And then there's another thing about do support here, but let's just ignore that for the moment. What is this talking about? It's talking about how you make yes-no questions out of statements in English. This is presumably something that's encoded in your syntactic grammar. And so we're going to only consider statements with auxiliary verbs for the moment because it's simpler this way. So, John has eaten is a statement. If you wanted to ask a yes/no question about that in English, you would invert the subject, John, and the auxiliary verb, has, and that would be the question, right? Has John eaten? Similarly, the children are eating. Are the children eating? Inverting not the subject, which is the children, and the auxiliary verb are in that example. And in general, the claim is that, or the hypothesis is that, this is how you form yes/no questions in English. What's the null hypothesis? I mean, the sort of obvious simple mapping I've given you would suggest English yes/no questions are not formed by yada yada yada, inverting the order. This is not at all a useful null hypothesis. It's not giving you anything to investigate. And so the observation here is just that as you get more complex research questions, you're going to need more complex hypotheses to compare them to, right? Rather than just sort of this simplistic idea of, well, maybe there's nothing going on here at all. That's sort of a non-starter when we're in these areas with a little bit more substantial theory in them, right? Here's a couple possibilities for things that you might actually want to ask here. The strictest one, there's no relationship between the word order of a yes/no question and the corresponding declarative, but that's sort of the null hypothesis, but it's a really silly hypothesis to spend time on because anybody who knows English knows that that's not true. And it's just not a helpful thing to try to investigate. So here's my suggestion for a more interesting alternative that's still more basic than phrasal inversion, which is how I'd paraphrase the original one up there. English yes/no questions are formed by inverting the first and second words of the sentence. Right? John has eaten. Has John eaten? Children love candy. Do children love? Sorry, that's a bad example because it again has that do support. Children are eating candy. Are children eating candy? So here, there's a bunch of questions where this hypothesis, reverse the first and second words, makes the same predictions as the more complicated hypothesis, invert the entire subject and auxiliary verb. And the question is, how do you actually test between this hypothesis and my experimental hypothesis up here? And this is getting at the point that when you formulate interesting alternative hypotheses rather than sort of simplistic null ones, you end up being guided in your research to do more interesting comparisons. Namely, in this particular case, you would need a sentence where the subject and the auxiliary of the sentence are not the first and second words of that sentence. And I've already mentioned one of these. In particular, you would need a sentence where the subject is more than one word long. So something like, the children are eating candy. If the experimental hypothesis is right, you should invert the auxiliary over the entire subject, the children, and get, are the children eating candy? But if this one is right instead, the alternative hypothesis, you should invert the first two words, which are the and children, and the question should be, children that are eating candy? So clearly, at least with regard to this data set, our experimental hypothesis is to be preferred over this alternative. But we've now sort of learned something interesting, namely that the process of forming a question in English syntax involves phrasal structure, not just a string of words. It's something that's sometimes referred to as structure dependence, and it's taken to be an important property of human syntax, not just of English. Of course, yes/no questions work in a number of different ways in other languages. This is only one possibility, but it's still illustrating an interesting property of languages in general, which is this structure dependence. So what are we getting at here? Well, experiments can only answer some kinds of questions, and those are generally going to be questions about comparisons between things, not really questions about the absolute value of things. Now, in some fields that are more physical sciences, there might be experiments where you're just trying to get very precise absolute measurements of some property. But in anything that's related to human language or cognition or mental activity, this is very rarely the object of study here. It's not really an issue of being able to measure things or get their absolute value. We're almost always looking at comparisons between different things in human behavior or in the human mind. So again, we're always going to have to ask this question, compared to what? And as we've just seen, the null hypothesis, sort of straightforwardly construed, is not always the best or even a possible alternative. And what this means is that we might need to alter our research designs in ways that examine alternative hypotheses more carefully. And in particular, this relates back to the idea of experimental control that we talked about earlier. Right? So experiments have the advantage of being controlled, sometimes to set up strict control in an experiment so that you can be sure your results pertain to the effect or the factor of interest. You need to set up a control condition to be compared to your experimental condition. What do I mean by this? Well, here's again some more examples. Is the use of nouns embedded in real-life sentences a good method for teaching grammatical gender? And the next thing that pops up here, if you want to answer this question, well, compared to what? Compared to giving candy for right answers? Compared to some other method of teaching this? Compared to some other aspect of grammar? And this is going to arise for virtually any interesting research question you can come up with. And that means we're always going to need alternative hypotheses that may go beyond the null hypothesis. So in this case, I guess the null hypothesis would be something like compared to nothing. So test students before they've had any instruction whatsoever in grammatical gender, expose them to nouns embedded in real-life sentences, test them again afterwards, and if they improve, then the method worked. Right? This is a very simple kind of experimental setup, but there's some problems here. So to pause it for a minute, what's the problem with this setup? One big problem here is that you don't know what would have happened if you'd used some other teaching method, right? The alternative to teaching grammatical gender using real-life contextual examples, the alternative to that is not teaching them nothing at all. It would be teaching gender in some other way, right? So we're going to want to actually compare this to some kind of a simpler or more standard kind of a method, right? So in this case, you might want to use a control group where the control group gets a more typical method of instruction or something like that, or a simpler method of instruction. Right? Is the use of nouns embedded in real-life sentences a good method for teaching grammatical gender compared to simple rote memorization? So here, in order to test this, now all of a sudden, we're going to have two groups. We're going to test both of them before instruction to make sure that the two groups didn't just start out being really different from one another. One of those groups is going to be given word lists to memorize with gender. That's the control group. And one of them is going to be given examples of sentences with different nouns embedded inside them. We're going to test both groups over again and compare how much the two groups improve. Right? So the question here is not just does this help teach gender, but does it help teach gender better than some obvious alternative? Now with our experiment, all of a sudden, we're testing a difference between differences, right? So the difference between pre-training performance and post-training performance between the control group and the experimental group. And this is called an interaction design. And in the statistical analysis, we're going to refer to this difference between the groups as an interaction effect. Most of the interesting research questions in the language sciences and the educational sciences, most of the human and social and behavioral sciences are going to be questions about interactions. This makes them, to some extent, inherently more complex than you might expect from a simple planned comparison. An interaction measures whether two differences are different. So if we have, for instance, two conditions here, this might be like the teaching exercises or some other manipulation that we're doing. And we have condition A and condition B. And then we're looking at some type of measurement of type X and compared to another one of type Y. So in the example you've just given, maybe this is pre-training versus post-training performance or something like that. The interaction asks, does the difference between X and Y that we found in condition A change in condition B? And interestingly, this is exactly equivalent to the other question, the other way of phrasing this question. Does the difference between conditions A and B that we found for items of type X change for items of type Y? So you can look at this as comparing this difference to this difference, right? We're going to put these two things next to each other, and we'll have the interaction of this XY contrast with the AB contrast over here. Most things in human, social, and behavioral sciences are questions about interactions. So here's, again, a bunch of exercises. Maybe I'll split this out. This video is getting a bit long, so I'll do this in a separate video. And we're going to try to think about what kinds of control groups or comparisons we might want to use in approaching some research topics.